This is Science Encyclopedia College. Today we are going to be having lesson 2 on the topic, the concept of energy stored in a capacitor. Now the question says, use the diagram to calculate the effective capacitance and the energy stored by the capacitors. So I did say in my first video or lesson 1 on this particular topic that the energy stored in the capacitor is the same thing as the work done in charging that capacitor. Now, this question now says we should calculate. There are two parts of this question. We have two questions here. Calculate the effective capacitance and the energy stored by the capacitor. So, even if the question did not ask you to calculate the effective capacitance, and it only says you should calculate the energy stored by the capacitors, you cannot calculate the energy stored by the capacitors without knowing the effective capacitance. So the question must always have either you are giving the capacitance in the question or you'll be given a diagram that you will need to calculate the effective capacitance. So if they want to twist the question, what they will do is they will not tell you to calculate the effective capacitance. They will only ask you to calculate the energy stored by the capacitors and then giving just a diagram. So take note, you must always resolve the capacitors here to get the effective capacitance. Now there are two arrangements that these capacitors can be given, either in the series arrangement or in a parallel arrangement. But the question on the board is a series arrangement. They are in series. So we have here series arrangement. The formula is 1 over C effective equals to 1 over, depending on the capacitors, 1 over C1 plus 1 over C2 plus 1 over C3, since they are 3. So to now become 1 over C effective is going to be equals to 1 over the first value there plus 1 over 6 plus 1 over 6. So if we do this properly, I'm going to be having the LCM, let me have it here, 1 over C effective equals to, the LCM of 666 is 6, so write the LCM, 6 divided by 6 is 1, 1 times 1 is 1, plus 6 divided by 6 is 1, 1 times 1 is 1, plus 6 divided by 6 is 1, 1 times 1 is 1. So if we plus this, we are going to have 1 plus 1 plus 1 is going to give us 3 over 6. So you are going to be having 1 over C effective is going to be equals to 3 over 6. If you divide it here, 3 here 1, 3 here is 2. We have 1 over C effective. Let me have it as a subscript. C effective will be equals to 1 over 2. And what we're looking for here is C effective, so we cross multiply. C effective, or 1 times 1, or C effective times 1 is C effective equals to 1 times 2 is 2. So what we have here is C effective equals to 2. So 2 microfarad. That's in units. So we have gotten the effective capacitance as this. So from the effective capacitance, we can now calculate the energy stored by the capacitors, because the formula is giving us, we can say therefore it is given as W equals to 1 over 2 multiplied by C multiplied by V squared. That's the voltage. Now the voltage is given here as 100. We have V equals to 100 volt. So we substitute it, we already know our C. So we're having W is going to be equals to 1 over 2 times 2 microfarad is times 10 to the power minus 6 times the V squared is equals to 100 times 100. We have W equals to, if you press your calculator, okay, 0.5 times 2 times 10 to the power minus 6 times 100 times 100. Okay, so we have 0.01. This is the same thing as 1 times 10 to the power. We change it to standard form 1 to minus 2. Work done is in joules. So we can have our answer as either 0.01 joules or 1 times 10 to the power minus 2 joules. So this is the answer to this question. Thank you for watching. And don't forget to like, to share and to subscribe to my channel for more videos.